Okay, so part 3 now. So we figured out all this part of the circuit. Now, next thing that's important, and bear with me or just trust me at first and you'll see why it's important. We got a voltage drop here, 1.5, 7.5, 3 volts. So if you add those together, 7, 8, 9, 10, 11, 12. If you were to take a multimeter and measure across here, that's going to give you 12 volts. Why is that important? Well, it's important because this is the same. These are the same nodes. What I mean by that is these points here in real life and these points here are going to be the same nodes, the same terminals. Twist those wires together. Consequently, you know that the voltage drop on this, because again, there's no other resistors or bullshit here, is going to be 12 volts. That also means that you can calculate what current is flowing here. Because again, we know what current's flowing here, but because we have different resistance on this line, we don't know what current's flowing here, and we also don't know yet what current is flowing here, because that's the sum of those. Shembry's saying he posted a video online. He can go fuck himself. I like mine better. Alright. So, we know that. We got voltage. We know resistance. We're trying to figure out the current. Well, guess what? We got all the information we need for that now. And that calculates to 0.2 amps. Reminder again, all that is I equals V over R. Sweet. So, this is a big deal for a couple reasons. We know the current flowing here, and we know the current flowing here, which means we know the current that's going to flow here and here. Because remember, think of current flow like a pipe. It's water right now. It's an oversimplification for certain things later on, but for 99% of it, you can think of it that way. So if we got 0.2 amps flowing here, 0.3 amps flowing here, you just add those suckers up. And same thing here. We have 1 amp flowing here. No clue what's flowing here, but we already know it's flowing here. It's 0.5 amps. Because remember, it's going that way, and then it's splitting off here. So it just so happens we calculate already. We got 0.2 amps of that flowing that way, 0.3 amps of that flowing that way. So that means now we can figure out what R2 is, because we know there's 0.5 amps flowing there, and you got 12 ohm resistor there. So figure out voltage, V equals IR. And what is that? Calculated 6 volts for that? Yeah, that's right. So we got 6 volts. Alright. So that completes most of the circuit right there. We're going to go on the next side here, next video here. I think that'll be part 4.